Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we're going to continue our lesson for topic of what we call topic 4 matrices and system of linear equations with subtopic of 4.3 inverse of a matrix. Okay, so as we know that last time we discussed about addition. Okay, addition of matrices of A plus B with the same size of A and B. Subtraction. Okay, matrices of A minus B and multiplication. Multiplication we call multiply between the we call matrix of A and B, but there is no division divide between A and B. Okay, so for matrices there are no divide between A and B, but there's come the inverse we call idea of inverse as the opposite of the multiplication. Okay, so at the end of the lesson, students should be able to compute the inverse of non-singular matrices. Okay, to compute the inverse using the adjoint method, elementary row operation, and include of AB equal to KI. So this I represent the matrix of identity for matrix of 3 times 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So adjoint matrices is let's say C is a cofactor matrix of A. So adjoint of matrix A is defined as a transpose. Okay, the transpose of the cofactor matrix, that is this one here. Okay, so please refer to your lecture notes. Please refer to your lecture notes. We call the notes, and this explanation is exactly the same. Okay, so now, do you still remember the cofactor of matrix of 3 times 3? First, we're going to find out the minor of the matrices 1 by 1. Okay, the minor 1 by 1, and then we are dealing with a sign of positive and negative with this pattern. I do believe that all of you remember what I discussed in the previous previous subtopic of this. Okay, so then it's time for us to use it now, minor and cofactor, to find the adjoint of A. Okay. Okay, let's say this is a matrix here. So now we are going to find the minor of 1, 1, M1, 2, M1, 3, M2, 1, M2, 2, and M2, 3, M3, 1, M3, 2, and M3, 3. Okay, the first one then. From here, minor 1, 1, meaning we are going to hide the element in row 1 and column 1. Okay, so what's left here now? We got 2, 4, 1, 3. 2, 4, 1, 3. So 2 times 3 equal to 6 minus 4 times 1 equal to 4. 6 minus 4 equal to 2. Okay, next. We call hide the element in row number 2 here. So what's left here now? We got 3, 4, 1, 3. 3, 4, 1, 3. 3 times 3 equal to 9 minus 4 times 1 equal to 4. 9 minus 4 equal to negative 5. Okay. Then hide the element in row 3. So what's left here now? We got 3, 2, 1, 1. 3, 2, 1, 1. 3 times 1 equal to 3 minus 2 times 1 equal to 2. So 3 minus 2 equal to 1. Okay, now time for us to hide the element in row 2 and column 1. According to the order here, this is represent row number 2 and this one column number 1. Row 2, column 1. So then what's left here now? We got 2, 3, 1, 3. Okay. So 2 times 3 equal to 6 minus 3 times 1 equal to 3. So 6 minus 3 equal to 3. Okay, next. Okay. Hide the element in column 2. So then what's left here now? We got 1, 3, 1, 3. 1, 3, 1, 3. 1 times 3 equal to 3 minus 3 here. So 3 minus 3 equal to 0. Okay, next. Hide the element in row 3. So what does it have here now? 1, 2, 1, 1. 1, 2, 1, 1. 1 times 1 equal to 1 minus 2 times 1 equal to 2. So 1 minus 2, negative 1. Okay, now it's time for us to look at the element in row 3. Hide the element in row 3 and column 1 first. Okay, so what's happening now? 2, 3, 2, 4. 2, 3, 2, 4. 2 times 4 equal to an 8 minus 3 times 2 equal to 6. 8 minus 6 equal to 2. Okay. Column 1, then let's go to column 2. So what we have here now? 1, 3, 3, 4. 1, 3, 3, 4. So 1 times 4 equal to 4 minus 3 times 3 equal to 9. 4 minus 9 equal to negative 5. Okay, and then next. Hide the element in row 3. Then M33. So we have here now, we have 1, 2, 3, 2. 1, 2, 3, 2. 1 times 2 equal to 2 minus 2 times 3 equal to 6. So 2 minus 6 equal to negative 4. Okay, so now the adjoint, okay, cofactor of A. Cofactor of A, take this to negative 5, 1, 3, 0, negative 1, 2, negative 5, negative 4, multiply with positive, negative, positive. Okay, so for example, 2 times positive equal to 2. Negative 5 multiplied with negative sign here equal to 5. And then 1 multiplied with 1 positive here equal to 1. 3 multiplied with negative, negative 3. 0, 0. Negative 1 multiplied with negative equal to 1 here. 2 times positive equal to 2. Negative 5 multiplied with negative, it gives you positive 5. Negative 4 multiplied with positive, negative 4. Okay, so this is the cofactor of A. Now, okay, I'll solve all this in just one page here. Says that this is a recorded, so you may recall, use, press a button of play, stop, forward, pause, rewind. If you think that my explanation is very fast, and you may repeat to watch it and hear it again and again. So now, this is a cofactor of A. Okay, I'll rewrite here. Cofactor of A equal to 2, 5, 1, negative 3, 0, 1. And 2, 5, negative 4. So then the adjoint of A is a transpose of the cofactor of A. So then transpose of this, we call matrices 2, 5, 1, negative 3, 0, 1, 2, 5, negative 4. The process of transpose, we interchange between a row and column here. So then it's now 2, 5, 1 from the row become column 2, 5, 1. Row number 2 become column number 2. And row number 3 become column 3, 2, 5, negative 4. There you go. Okay. Next. The process that I hiding all the elements just now. There are three methods to obtain the inverse of a matrix adjoint. So class determinant, we have learned it before, how to find a determinant. Recall the summation of the multiplication with the element multiplied with the cofactor of that element and multiplied with the adjoint of A. Adjoint, the thing that we have discussed just now. Okay. Use the property of AB equal to KI for this one. Okay, we're gonna look into the example later. Element and then next elementary row operation. Okay, so now A inverse is not equal to 1 over A. So there's no there's no division in this topic of matrices. Okay, what we have is only an inverse. Okay. A is a non-singular matrix. Inverse matrix exists here when the determinant of A is not equal to 0. And if the determinant equal to 0, A is a singular matrix and inverse does not exist. Okay. So find the inverse of B. Okay. A matrix of B. Matrix of B, we have 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. Okay, let's check. 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. Okay, so now we are going to find out the determinant of B. Determinant of B. Okay, first we decide which row or column have the 0 most. Okay, we can rely on row number 2 or column 3, either one. Okay, so we're going to choose row number 2 first with 0 and then multiply with negative 1 to the power of, okay, this is a row 2, column 1, 2 plus 1. And hide element in row 2 and column 1, you get 3, 2, negative 1, 0. 3, 2, negative 1, 0. Okay, plus with 2 and negative 1 to the power. Okay, the position of this is a row 2 and the column 2. So it is now 2 plus 2. And the minor hide the element in row 2 and column 2, you will get 1, 2, negative 2, 0. 1, 2, negative 2, 0. Then plus with 2 and negative 1 to the power of the position of this is in row number 2 and column 3. So 2 plus 3. And the minor here, hide the element in row 2 and column 3. We got 1, 3, negative 2, negative 1. 1, 3, negative 2, negative 1. So class, for this one, any value of this cofactor multiplied with 0 is straightly we give you 0 here. So then 0. Okay. Negative 1 square equal to 4. And then 2 plus 2 equal to 4. Negative 1 power of 4 is positive. So plus with 2, and the minor 1 times 0 equal to 0 minus 2 times negative 2 equal to negative 4. Okay, plus with 2 plus 3 equal to 5. So we got 2 and negative 1. Negative 1 power of even odd numbers, negative 1 here. So 1 times negative 1 equal to negative 1 minus 3 times negative 2 equal to negative 6. Okay, so negative times negative equal to positive. 0 plus 4 equal to 4 times 2 equal to 8. 0 plus 8. Negative times negative become positive. So 6 minus 1 equal to 5. 5 times 2 times negative equal to negative 10. So 8 minus 10 equal to negative 2. Okay. So we're going to find out the minor and cofactor of this one by one. M11, M12, M13, M21, M22, and M23, M31, M32, and M33. Okay, so now for M11, hide the element in row 1 and column 1. So what you see here, guys, 2, 2, negative 1, 0, 2, 2, negative 1, 0. So 2 times 0 equal to 0 minus 2 times negative 2 equal to negative 2. So 0 plus 2 equal to 2. Okay. Then hide the element in row 2. So what you see here now, we got 0, 2, negative 2, 0. 0, 2, negative 2, 0. 0 minus 2 times negative 2 equal to negative 4. So 0 plus 4 equal to 4. Okay. And hide the element in row 3. So what we have here right now, we have 0, 2, negative 2, negative 1, 0, 2, negative 2, negative 1. Negative 0 times negative 1 equals 0 minus 2 times negative 2 equal to negative 4. So 0 plus 4 equal to 4. Okay. Right now, we will look into the element in row 2 and column 1. Row 2 and column 1. So what we have here right now, we got 3, 2, negative 1, 0. 3, 2, negative 1, 0. 3 times 0 equal to 0 minus 2 times negative 1 equal to negative 2. Negative, negative become positive. So 0 plus 2 equal to 2. Okay, hide the element in row number 2. Okay. So we have here now 1, 2, negative 2, 0. 1, 2, negative 2, 0. 1 times 0 equal to 0 minus 2 times negative 2 equal to negative 4. So negative, negative become positive. 0 plus 4 equal to 4. Okay, and wait. Then hide the element in row 3. Okay, so we have 1, 3, negative 2, negative 1. 1, 3, negative 2, negative 1. 1 times negative 1 equal to negative 1 minus 3 times negative 2 equal to negative 6. Negative become positive here. So 6 minus 1 equal to 5. so for M31, okay, so hide the element in row 3 and column 1. So what we have here right now, we got 3, 2, 2 and 2. 3, 2, 2 and 2. 3 times 2 equal to 6 minus 2 times 2 equal 4. 6 minus 4 equal to 2. Okay. Hide the element in row 2. Then we got 1, 2, 0, 2. 1, 2, 0, 2. 1 times 2 minus 2 times 0 equal to 0, then equal to 2. And here for this, we have 1, 3, 0, 2. 1, 3, 0, 2. So 1 times 2 equal to minus 3, 0, then equal to 2. Okay, so now these all the minus of the matrices. Then next we are going to find out the cofactor of this matrix of B. Cofactor of B equal to, okay, so I do hope that you still remember this. Positive, negative, positive, negative, positive, negative, positive, negative, positive. So first with 2 here, multiply with positive, then we got positive 2. 4 multiply with negative, negative 4. 4 multiply with positive, 4. 2 multiply with negative, we got negative 2 here. 4 multiply with positive, 4, and 5 multiply with negative, negative 5. Then 2 times positive, 2. 2 multiply with negative, negative 2, and 2 multiply with positive, 2 here. Okay, so now, once we're complete, find the minor, cofactor, and determinant. Okay, so class, we already have the, we call determinant, cofactor, and we need to find the adjoint. Then adjoint of B equal to transpose of the cofactor of B, which is 2, negative 4, and 4. 2, negative 4, and 4. Negative 2, 4, negative 5. Negative 2, 4, negative 5. Negative 2, negative 2, and 2. Negative 2, negative 2, and 2. Wait, this is not negative. This is the sign of the bracket here. Sorry. Sorry then. Okay, again, the adjoint 2, negative 2, and 2. Yes, negative 4, 4, negative 2, 4, negative 5, and 2. Okay, so the adjoint of this matrix of A, so then B inverse equal to 1 over determinant of B multiplied with adjoint of B. Okay, so 1 over, we call determinant is negative 2. Okay, then we got 2, negative 4, and 4. Negative 2, 4, and negative 5. 2, -2, and 2. There you go. So this is a matrix inverse of B then here. Okay. So the properties of inverse, the inverse of the A inverse, it gives you back the matrix of A, and the transpose of A, once we inverse it, equal to A inverse, and we transpose that later. Okay. And also for this one here, and determinant of A inverse equal to 1 over determinant of A. Okay. So class, in this case, if AB equal to a scalar of alpha multiplied with the in what we call identity of I, it's gonna be like this. A inverse multiplied with A and B equal to A inverse scalar of alpha with an I. So for this one, it give you an I and B, and scalar is still scalar than here. So A inverse multiplied with identity, and identity multiplied with the matrix of B equal to B, and this one here, any matrices multiplied with the identity, it can give you the identity itself. No, the inverse itself then. Okay. So then A inverse equal to, bring this to the other side here, A inverse equal to 1 over alpha multiplied with B. Just like this. Okay. Okay, so just like recall A times B equal to identity where A and B are square matrices, then B is called the inverse matrix of A and written as an A inverse. So look at this one. If A multiplied with matrix of B, when B is the inverse, or B multiplied with the A, when the A inverse of we call A inverse multiplied matrix of A equal to an identity. Okay, so now find the inverse of using the property of AB equal to KI. It's known that AB equal to KI, where K is a constant and I is a 3 times 3 identity matrix. Find K and hence deduce the A inverse. Okay, so then next, let's say matrix of A multiplied with B. So first, we're going to look into the element in first row with element in the first column. So then, it is 1 multiplied with 1. 1 multiplied with 1 plus with 2 multiplied with negative 10. 2 times negative 10 plus with 3 multiplied with 7. Okay, that is the first one. Then, we make operation between the element in row 1 again with element in second column or column 2. 1 multiplied with 1 plus with 2 multiplied with 4 and 3 multiplied with negative 3. Okay, and then next, the element in row 1 with column 3. So 1 multiplied with negative 1, 1 multiplied with negative 1 plus with 2 multiplied with 2 plus with 3 multiplied with negative 1. Okay. Okay. Then next, we're going to look into the element in row 2. and element in column 1. So 2 times 1 plus with 3 times negative 10 plus with 4 times 7. Okay, then next, the element in second row and second column, 2 times 1 plus with 3 times 4 plus with 4 times negative 3. Okay, and then the element in second row and the third column, so we got 2 times negative 1 plus with 3 times 2 and 4 times negative 1. Okay, now plus. Sorry. Okay, so then next, we'll complete the element in row 2 and column 3 here. Then we're going to make operation between row 3 and this column 1. We got 1 multiplied with 1 plus with 5 multiplied with negative 10 plus with 7 times 7. Okay, and then next, multiplication between element in row 3 and column 2. 1 multiplied with 1, 5 times 4, and 7 times negative 3. Okay, and then multiply between element in row 3 with element in column 3 of the other, what you call of the other matrices here. 1 multiplied with negative 1, then 5 times 2 plus with 7 times negative 1. Okay. So class, okay, I'm going to make it short for this discussion here. You may count one by one. You should get this as a 2 0 0 0 2 0 0 0 2. Okay, you should count it one by one and make sure that this is the one that you're gonna get. So guys, 2 2 and 2 here, we just say 2 and then without 1 0 0 0 1 0 0 0 1 or 2 multiplied with an I. Okay. So the next, and then the third row with every column then here. Okay, so now A multiplied with B equal to 2I. So then K equal to 2. Okay, so now, and hence A inverse equal to 1 over 2 B, which is 1 1 over 2, and B is 1, 1, negative 1, negative 10, 4, 2, and 7, negative 3, negative 1. Okay, as we know that A, B equal to 2I. So we come up with A inverse on left and right side. So the A inverse multiplied with all its own and equal matrices of A is going to give you an I, B, and then 2 where we got A inverse multiplied with an I. Okay. When the matrix of A multiplied with its own inverse, automatically it's going to give you a matrix of identity. And matrix of identity multiplied with any matrices is going to give you B, and this one is a 2A inverse. So then A inverse equal to 1 over 2 B. Okay. You know. Okay. So then A inverse equal to, it is 1 over 2, 1 over 2, negative 1 over 2, negative 5, 4 divided by 2 is 2, 1, 7 over 2, negative 3 over 2, and negative 1 over 2. Okay, there you go. Okay. Then next, example 4, given an A, find the values of M and N such that A squared plus we call a constant of M, scalar of M multiplied with A, and Ni equal to 0, where I is a matrix of identity, 3 times 3, and 0 is a matrix of 0. Matrix of 0 means that, okay, matrix of 0 means that all the entries are 0. Okay, use this relation to obtain A inverse and show that this one here now. Okay. A squared, A and A, plus with the scalar of M with A, plus with N and identity equal to matrix of 0. Okay, so you should recall, show this one by one. You should get this one here, plus with this, and N with identity equal to 0s. Okay, so now let's say 7 plus M times 1, 7 plus M, and plus with 0 multiplied with N equal to 0, equal to 0. So we get the first equation here, 7 plus M equal to 0, then M equal to negative 7. And 11 plus 3M might be this 11 plus 3M, okay, and 1N equal to 0, okay, and 7M equal to negative 7 here. So we got N equal to 10. Okay. So now, when M equal to negative 7 and N equal to 10, okay, so just imagine that if we multiply with A inverse with all this, okay, A square means that A multiplied with A, then A inverse, minus 7A with A inverse, plus 10 identity with A inverse equal to 0 multiplied with A inverse. Okay, so 0 with A inverse, straightly give you 0 here. Okay, so now A multiplied with A inverse, then we get A multiplied with identity, and this also multiplied with 7 with identity, and this one identity multiplied with A inverse equal to 10, A inverse equal to 0. Okay, so then because we like to find the A inverse of this, so this is the one. Then A inverse equal to 7i negative, make it as a positive here, 7i and positive A and I. Positive A and I, A multiplied with identity equal to an A. So bring it here become negative minus A. Okay, so then A inverse equal to 1 over 10, 7 multiplied with identity multiplied with the matrix of A. Okay, so now A cube, matrix of A 3 times, which is A and A squared. Okay, where this one here now. Okay, class, so just imagine that this is a A square. Represent this, where A square equal to negative 7A being the side become positive. So 7A minus 10 identity here. Okay, 7A minus 10 identity. Okay, so then here 7A with A, 7A squared minus 10A identity. Okay, and look at this, we have A squared. We are going to use it again, so then it is 7. A squared is 7A minus 10I minus 10A. Okay, because A multiplied with identity equal to an A, so then 7 times 7, 49A minus 7 times 10, 70 identity minus 10A, okay, equal to 49A minus 10A, 39A minus 70I. There you go. Okay. Okay, find the inverse using elementary row operation. So guys, girls, in this case, we are going to use the elementary row operation. For example, we begin the process by writing the matrix of A and divide. And then next to it is a matrix of identity. Okay, then using the instruction of ERO until we get from A, from I on the left, on the right side here, the right side, it'll turn to the left side, and on this, the right side of identity on previously will become a new matrices, which is the inverse of the matrix of A. Okay. Okay, so these are we call the instruction or the order that we can use to find to solve these questions here. So we can use the instruction of interchanging the ith row and jth row, multiplying the ith row with a non-zero constant, and adding a multiple of 0 to the ith row here. Okay. Find the inverse of P using elementary row operation. Okay. Let's say P equal to, we have 2, 1, 1, 1, 1, 1, 2, 2, 1. Okay. Okay, firstly, we can write down the matrix of P. Sorry. Matrix of P on left side, we got 2, 1, 1, 1, 1, 1, 2, 2, 1. And the matrix of identity 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so class, according to we call the three orders that we call the order, the instruction that we can use here now, interchanging the I and j row, multiplying and adding multiple row, j and the I row here. So now we are going to bring this above here because we want it 1 on the top. Okay, this is our reference. We have identity 1 0 0 0 1 0 0 0 1. Okay, so we want it first here is 1. So interchange of R1 with R2. Okay, so once we make instruction or the order of this, interchange between 1 and 2 here, so the rest of the element just follow it, just follow the rules here. So we bring up here bring out the second row to the first row. We got 1 1 1 1 1 1 0 1 0 0 1 0 2 1 1 2 1 1 1 0 0 and 2 2 1 0 0 1 2 2 1 0 0 1. Okay, then next we are going to make this, turn it into 0 as this one here now. So we come up with the new R2 equal to negative 2 R1 plus R2. So just imagine that negative 2 multiplied with element R1. This is the new element in row number 1, not the previous, the latest one here, the current one here. So negative 2 times R1. Just imagine that negative 2 multiplied with 1. Negative 2 multiplied with 1 plus with R2. What is the element in R2? Yes, 2 here. Plus 2. So negative 2 plus 2 equal to, yes, 0. Okay, this is operation for row number 2, meaning row number 1 and row number 3 remain, nothing changed. 1 1 1 0 1 0 2 2 1 0 0 1. Okay, now negative 2 times 1 equal to 2 plus 2 equal to 0. Then negative 2 times 1 equal to negative 2. Negative 2 plus 1, negative 1. Negative 2 times 1 equal to negative 2 plus 1 equal to negative 1. Negative 2 times 0 equal to 0. Negative 2 times 0 equal to 0 plus 1 equal to 1. Negative 2 times 1 equal to negative 2 plus 0, negative 2. And then negative 2 times 0 equal to 0 plus 0 equal to 0. Okay, next, we're going to change this to turn it into 0 here. And we will make operation between these two with a 1 from row number 1 here. So the new R3 equal to negative 2 R1 plus R3. Okay. So now we are talking about the we call element in row number 3, instruction in row number 3. So element in row 1 and row 2, nothing changed. 1 1 1 0 1 0 0 negative 1 negative 1 1 negative 2 0. So negative 2 times 1 equal to negative 2. Negative 2 plus 2 equal to 0. Negative 2 times 1 equal to negative 2 plus 2 equal to 0. Okay. Negative 2 times 1 equal to negative 2 plus 1 equal to negative 1. Negative 2 times 0 equal to 0, plus 0 equal to 0. Negative 2 times 1 equal to 2, plus 0, negative 2. Negative 2 times 0 equal to 0, plus 1 equal to 1. Okay, luckily we got this 0. Okay, actually if this is not 0, we need to come up with another instruction, but since that because of this instruction we straightly get it 0 and it's fine. Now we are targeting on this. Okay, look at this. The new R2 equal to negative 1 multiplied with R2. Okay, so nothing changed in row number 1 and row 3, so we got 1, 1, 1, 0, 1, 0, 0, 0, negative 1, 0, negative 2, 1. Okay, 0 multiplied with negative 1, negative, positive 1, negative multiplied with negative 1, positive 1, negative 1, positive 2, and 0. Okay, so then next, from here, 1, 1, 1, 0, 1, 1, 0, 0, negative 1. Okay, we move to the next page. Continue with the next page here. 1, 1, 1, 0, 1, 1, 0, 0, negative 1. Okay, 0, 1, 0, negative 1, 2, 0, 0, negative 2, 1. 0, 1, 0, negative 1, 2, 0, 0, negative 2, 1. Okay, so then next, we are targeting on this part, this one here, because this is our reference 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. So we are focusing on this one here now, this part here now. So what we're going to do is we're going to come up with the new R1, which is negative 1 R2 plus R1. Okay, so there will be changes in element in row 1, but nothing changed in row 2 and row 3. So we rewrite the row we call element in row 2 and row 3. Okay, first 0, 1, 1, 0, 0, negative 1, negative 1, 2, 0, 0, negative 2, 1. Okay, so negative 1 times R2, negative 1 times R2 plus R1 equal to 1. Negative 1 multiplied with 1 here, R2. Negative 1 times 1 equal to negative 1 plus 1 equal to 0. Negative 1 times 1 equal to negative 1. Negative 1 plus 1 equal to 0. Okay. So negative 1 times R2. Negative 1 times negative 1 equal to 1 plus 0 equal to 1. Negative 1 times 2 equal to negative 2 plus 1 equal to negative 1 and 0, 0, 0. Okay. 1, 0, 0, 1. Okay, so we're going to change this negative 1. This is our reference here now. So the new R3 is equal to negative 1 multiplied with R3. So we got 1, 0, 0, 0, 1, 1, 1, negative 1, 0, negative 1, 2, 0. Okay, multiply with negative 1, 0, 0, 1, 0, 2, negative 1. So now the new R2, which is equal to -1 multiplied with R3 plus R2. -1 multiplied with the element in R3, which is 1 here. So element in row 1 and row 3 remain 1, 0, 0, 1, -1, 0, 0, 0, 1, 0, 2, -1. Okay. -1 multiplied with element in R3, 0 and 0, 0. 0 plus 1 equal to 1. So -1 multiplied with 1, -1. -1 plus 1 equal to 0. -1 multiplied with 0 equal to 0 plus -1, -1. -1 times 2 equal to -2 plus 2 equal to 0. -1 times -1 equal to 1 plus 0 equal to 1. Okay, so now class, we got 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is an identity and this is the P inverse. So P inverse equal to 1, -1, 0, -1, 0, 1, 0, 2, -1. 0, -1, 0, 1, 0, 2, -1. Okay, so class, this is quite a long process for you to understand the ERO, elementary row operation. Okay, so you may repeat, rewind, and repeat watching this with explanation again and again and again, and try with a few questions to make yourself what we call master with in this process. Okay, so now then finally, so the conclusion that find the adjoint of A is the transpose of the cofactor of the matrices, and A inverse equal to 1 over determinant multiplied with the adjoint of A. So find the inverse of using elementary row operation using the process of ERO until you get, we call the new matrices on the right side, replace the identity that we call switch the position from the right side to the left side of the process, and this is the inverse of the matrix. Okay, so that's all for today. Thank you very much till we meet again, and hopefully that this video benefit all of you, my students. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.